Vinny!
That's what I'm talking about.
Wait!
Okay, now, from the beginning.
Good afternoon. All right. Hope you guys are having a wonderful GDC. And I think it's pretty awesome that Unity invited us into their awesome, beautiful offices. So a quick round of applause for Unity for hosting us. How awesome is that? So my name is Vinny DaSilva, and I'm a developer evangelist with Vuforia. And so how many of you guys know or are familiar with Vuforia? Oh, cool, lots of you, awesome, cool. Well, for those of you who don't know, Vuforia is an augmented reality engine that's integrated into Unity. And if my slides are working. All right, back to your regularly scheduled program. Okay, so where was I? Oh yeah, so Unity, Vuforia. Vuforia is integrated into Unity. We're an augmented reality engine. And what we do is that you guys as Unity developers continue creating your content inside of Unity. And then with Vuforia, we allow you guys to bring it into the real world. The way that we like to think about it is that Vuforia sort of gives your app, your experience, your game, an eye into the world. So we use advanced computer vision to understand the world. And in particularly, we can understand your environments, and we can understand your objects. Today in the market, there's over 50,000 Vuforia-powered apps that have been published in the various app stores, with under the 50,000 that are actively in development. Not only do we work alongside mobile devices, handheld mobile devices like phones and tablets, we also work on a ton of headworn devices, and we're always expanding both the amount of devices we support, both handheld and headworn. So Vuforia, when we think about putting content into the real world, we think about putting content into two different types of places. We think about putting content onto objects. So that's things like books and posters, catalogs, toys, bottles, packaging, toys, machinery, industrial equipment, any kind of physical object that you want to put content on top of, whether they're instructions, whether they're gameplay mechanics, or any sort of creative sort of take on the content and the objects. A lot of the Vuforia apps that you see today work with this sort of technology where we're observing the world, seeing objects, recognizing objects, and putting content onto those objects. Now, we also put content relative to the environment. So we can put content on the floor, on a table, in the middle of a room. And that's all of our environmental-based technology. A lot of what you see with Snapchat, a lot of what you see with things like Pokemon Go, use this sort of technology to put content into environment ahead of time. So first thing that we're going to do is we're going to go into a little bit of detail about the types of objects you can put content on. And then we're also going to talk a little bit about, afterwards we'll talk a little bit about putting content onto the environment. So placing content onto objects. So Vuforia has a lot of different ways to give developers the opportunity to put content onto objects. One of these ways is something that we call a view mark. And a view mark is really interesting in the sense where not only can you put your virtual content on an object, but you can store data in a view mark, and you can sort of identify an object down to serial number. So if you have a lot of machinery, or if you have a lot of equipment, or if you have toys, you want to do unlockables, you probably want to use something like a view mark where not only can you recognize it and understand it, but you can store data in it. The way that we like to think about it is that it's like a QR code, but looks a lot better because your designers can actually configure the view mark. Image targets are our bread and butter for augmented reality, and this allows you to put content on things like posters, books, any kind of flat 2D image. It's really popular with posters for movies. It's also really popular for billboards, card games, board games, all sorts of things like that. Take advantage of image targets. Cuboids are when just a flat 2D image isn't enough, right? So you're looking at something where you want to understand the packaging of a cereal box, any sort of packaging for consumer goods. In this way, the user can look at an object from any angle, and you can augment it. Cylinder targets are kind of fun. They're not used a ton, but they're really interesting use cases. And that's when we can recognize a 2D shape that's been transformed by a cylindrical object, like a bottle. There's a lot of interesting and popular applications that you may even use to track wine that uses this kind of technology. We also have a technology called object targets, and these are really useful for small, hard, rigid objects. They have a lot of features, and this is often used a lot with toys. Okay, so one thing that you may notice by looking at this is, what do all these objects have in common? All of these objects have rich visual detail that sticks out. And our computer vision algorithms takes advantage of that by detecting the natural features of the object and then be able to recognize it and track it in 6 degrees of freedom in space relative to the phone. But what if you have objects that don't necessarily fall under this category, right? When you have objects that are something like a car, right, which is reflective and shiny, really big, appliances in your home, 3D printed objects, industrial equipment, engines. These have all been notoriously really tricky for you to recognize and understand in augmented reality. And Vuforia has introduced a technology called model targets. This was launched late last year with Vuforia 7. And this is super cool technology. What you can do with this is that you can take a mesh model or an engineering model, a CAD model, import it in using the Vuforia tools, and it will generate for you a target based on the geometry. So what does that mean, and why is this interesting? Well, when we're talking about visual features, if you have a piece of equipment that wears out over time, it may change its visual appearances over time, right? It might have some wear and tear, it might get dirty, you might have some mud, all sorts of grime. Objects in the real world aren't always pristine, right? You guys know that. So with that being said, when we can use the geometry, we can detect an object and use the geometry to sort of place it in space. You have a lot more control of what you can do with it. So the color, the car can change, some of the minor details of the objects can change, and we'll still be able to track the object really well within 3D space. One of the things that for the Unity developers out there, we have a bunch of Unity samples in the asset store that work with these playing cards that are these Mars playing cards. And if you see me around, I should have some in my bag and I can give some out. Okay, so let's go over some details of the specifics of the different types of features that Vuforia can offer. So here we have a simple image target, and you can see that we're spawning in an astronaut on the card. So this card is maybe 3 or 4 inches big, and then we're detecting the features and putting the content on top of it. Here's an example of a cylinder target. And a couple of things I want to point out here. The first one being is that we're sort of having the augmentation be all around the object, right? So which really sells the experience. And the thing I want to point out here is that when you know the geometry of the object that you're working with, you can use that to your advantage. And you will notice as the drone is going behind this rocket booster, it's being occluded. Right? So traditionally, when we're doing augmented reality, because we're putting content on the frame of the camera, it usually renders on top of everything else. But when you have enough information about the geometry of what you're working with, you can do neat little tricks like this, where you can actually occlude things and make it look like it's going behind a real object. So this is an example of our multi-target, our cuboid, right? And you can see here we have a box where the cards would go under, and we have a bunch of sort of game state information available throughout the gameplay, and you can sort of see that it's being rendered on all sides. So this one here is, you can see it's not just a cube, it's a weirdly shaped object We scanned this one in using the scan tool, and we were able to generate an object target from it. And then you can see here that we're placing augmentations in different places. So you can still see the physical object, but then it's we're adding additional information. So in this case here, we have some game state, some gameplay information, right? So right now you can see that this hab has no oxygen, right? So in sort of the gameplay, you do want to make sure that there's something that's providing oxygen to this hab before the astronaut can use it. Cool. So one of the things that we're really proud of, one of our customers is named Merge VR. They're actually hanging out. I believe they're hanging out further back there at the AR Arcade. I highly recommend you guys check them out. They have a couple cool products. One of them is called the Merge Cube, which uses our cuboid, our multi-target. They also have a really cool new toy called the Six-Dot Blaster that does environmental-based things. But there are a couple of things I want to point out here is that there's two things happening here. So one of them is we're doing augmentation, where we're putting content and the user's rotating it. In the other case here, we see this slight outline of the cube, and the cube's actually being used as a controller. So as you're playing the game, you're moving the cube within your space to control the action. Another one of our super partners is SwapBots. They make these toys that they'll be selling soon, and the idea is that you can swap out different parts, and it uses Vuforia to determine which parts you've put together, and then you can battle out other players, and you can sort of customize what each individual bot's going to look like. Okay, so we talked a little bit about model targets, and I have a couple videos here showing off how this works. So this is a 3D printed object, and what happens here is that you have an initial snapping position. The user aligns that snapping position, and then you can sort of rotate around it. In this case here, we're putting a lot of content all around the 3D printed object. But that's sort of one of the things that you can do with it. You can anchor things down all around your 3D content. This is something else that I kind of played with within Unity. This is in Unity Play mode, where we have this flamethrower, and then we're aiming at our 3D printed object, and then we're putting in a texture over it. So the couple of things I want to point out that I find interesting about this little demo here is that normally, when we think about doing augmented reality, we think about putting content on top of it. So we want to change its color. We want to, sort of put all sorts of things all around the object itself. But the one thing that sometimes I feel like it's a little bit underused is this idea where once you know that the object is there, you can have other digital content interacting with the physical content. So in this case here, we have this digital flame. And then you'll notice as the fire gets close, it bounces off of our real object because we know its geometry. And then over time, we add in some shaders to make it look like it's melting. So I'll just show that again real quick. So it's a little subtle, but you can see here, can't pause it for some reason. You'll notice that as the flame comes down, it bounces off of the object itself, like right there. It's a little subtle. And then once it wraps up, and some smoke effects, it's pretty cool, and it looks like it's melting. So some things for you to think about, right, where not only can you understand objects, but what can you do with it when you're interacting with something that's physical and something that's digital. I think at Toy Fair, Hot Wheels announced, so Hot Wheels is having their 50th anniversary. They're creating, I don't know if any of you guys have played with any of this when you were kids, but I certainly did. So what's cool about this is that there's both the physical experience and the digital experience, where there's some gameplay elements. So normally, you sort of get this thing going, you press the button on your controller, and it just kind of goes on forever. What Hot Wheels is doing is that they're actually making it so that way you have to do pit stops. So that way, as a player, you need to think about when you're going to stop, and then you have all sorts of augmentations happening around it. And there's even interesting little tricks, like in Mario Kart, where you can disable the other car. You can do something very similar as well. So it's really interesting technology. Okay, cool. So that's objects, right? We looked at placing content onto images, onto cubes, and packaging, cylinders, models, toys, etc. Now we're going to talk a little bit about the environment, putting content on the actual environment itself. So Vuforia has been working with environments since 2013. Back then, we were using some depth sensing camera technology, and we were creating rich meshes of the environment where you can have some amount of semantic understanding and create potentially game levels or other sorts of content based on a semantic understanding of the world. But this technology always depended on world-facing depth sensing cameras. Ultimately, what we really want is we want to have a semantic understanding of the world or a better understanding of the world without any extra hardware, right? We want to use the phones that are in our pockets, understand the world, and augment the world. Vuforia has a technology now called ground plane that allows you to do just that. It allows you to detect environments, surfaces, outdoors, indoors, sort of tabletop experiences. And this is largely based around the idea of what Apple and Google have been doing, both with ARCore and ARKit. All right, so you might be thinking, how does this all fit together, right? How does Vuforia and ARCore and ARKit sort of fit together? So what we've done is we've introduced a technology called Vuforia Fusion. And the idea here is that Vuforia has a lot of technology that allows you guys to put content into the real world, right? That's our MO. That's our goal. Now, when we're talking about this sort of technology, we have all sorts of acronyms that we can throw at you between SLAM and VIO and all sorts of other things. So what happens here is that there's a lot of technology out there, and developers need to sort of figure out when to use which ones. And what we're trying to do is we're trying to make it really easy for developers to put content anywhere they want, anytime they want, and not have to worry so much about what device the end user is using, right? Because that's ultimately the really tricky part about AR, is that you guys don't know, A, what device they're running, and B, where they're running the experience, right? It could be in a really dark room, it could be in a really well-lit room, it could be a perfect place for augmented reality, or it could be terrible. So what we're doing is we've already included ARKit, and what this means is if you use Vuforia and you use our ground plane technology, and then you publish something to the App Store, if a user downloads it onto their iPhone 10, they'll put content into the world, and we're going to help keep it there by using Apple's ARKit, right? So they've spent a lot of time calibrating their sensors, creating optimal hardware, pairing it up with great software. So they have a really good approach of anchoring content into the environment. And we want to leverage that, and we want to allow you guys to use it as well. Now, if that same app on the App Store gets downloaded onto an iPhone 6, for instance, which does not support ARKit, we don't want that user not to be able to experience your game or your app, right? So what we will do is that under the covers, without you guys having to worry about it, we will pop into and use our visual inertial odometry system to keep content into the environment. Excuse me. Okay. So we also have ARCore, and ARCore is not implemented yet, but it will be out later this year. And that will be the same case where you create an application in Unity, it's cross-platform, you deploy it to the Google Play Store, somebody with a Pixel 2 will run it, and then we will leverage ARCore to keep it in place, to keep your content in the environment. But if somebody downloads it onto, let's say, a Galaxy S6, which does not support ARCore, we will then use our own visual inertial odometry system. And we'll keep expanding that. We're adding in support for UWP devices, tablets, so that way you guys can use that on Surface devices to put content into the real world as well. And then as we keep moving forward, we're going to sort of wrap up our Fusion story, where we were going to enable. So if any of you guys are familiar with Vuforia and you've used extended tracking, you guys are going to start to see extended tracking leverage things like ARCore and ARKit. right? So you're going to have a really tight integration into the hardware and what we call the AR enablers, right? The technology enablers underneath the devices that are there. Cool. So we have like maybe 7 or 8 different samples in the Unity Asset Store. Feel free to check them out. Just go to developer.vuforia.com to get information. And also, for those of you who are interested in getting early access software, we also have a program called the Innovator Program, where you can sign up for it and you can have early access to software. Right now, we're doing something really cool with our next generation of model targets. For those of you who are interested in it, check it out. And also, we should have some new announcements coming out in the next several weeks. And I think that's kind of it. I'm going to open up for a Q&A for you guys. Anybody who has any questions?
Hi, are you planning to work with HoloLens or, any AR glasses, Magic Leap?
Yeah, so one of my first slides I showed, so we currently support HoloLens, and we support the ODG R7s, the Vuzix M300. I think those are the ones that are actively in the market. Okay. We're certainly working with a lot of headworn AR glass vendors for sure. I can't say anything more specifically than that we haven't already announced. But absolutely, we're all over that space.
With regard to the model targets, I'm assuming you need some kind of a reference to detect a certain shape, like a mesh or something?
Yes, for model targets, the way that it works is that you need an original model, whether it's a mesh model or it's an engineering model, a solid model.
Yeah, so are there any limitations on that? Like, can we throw a CAD model at it, or is that too much?
You can, but you will likely have to go through simplification. So if you have a model with 50 parts and some crazy amount of polys, or you're gonna need to simplify it before processing it. Either because ultimately you will also have run into some issues in Unity itself if you're going to render it in Unity. Mm-hmm. But that's sort of you need to simplify it so that way the mobile CPUs and GPUs can handle it.
Thank you.
Sort of a similar question regarding the geometric model matching. The models, is it best to leave them in a line format? Your algorithm, do you use like line-based models or like a curve? And can I use, say, Blender? You were talking about simplified models, so I'm trying to get at how the models, what's the best format for the models to be in?
So because we're owned by PTC and PTC has Creo, we support I think 8 or 9 different types of formats. I don't know all the formats off the top of my head, but we support both mesh and solid models. If you want to get more specific, we can take it offline and I can try to dig up the specific types of formats. But generally, folks either can generate one of the models that we support, or it's pretty simple to convert it.
Okay, thank you.
Absolutely. Awesome. Seems like that's it. Well, thank you guys so much for your time. Again, my name is Vinny DaSilva. Feel free to reach out to me on Twitter. I'll be around GDC I'll probably be here at Unity Central for the rest of the day today. I'll probably be hanging out GDC tomorrow. Feel free to ask me any questions. I'll be glad to talk about your projects or any questions you might have. Thank you so much. Have a wonderful GDC.